Today we're going to be discussing scalable games and analytics with AWS, and we've got Nate from our solution architect team who will be taking us through some of the examples as well as a lot of the architecture behind some of the highest performing games that are around. A couple of notes first. My name's Dave Pierce, and I'll be leading Q&A. So we do have a couple of breaks during the course of the presentation to stop for Q&A after sections. So if you have specific questions you want to ask during the slides, please pop them into the question window, and we'll get to them interactively as we go through the session. We'll also end with a longer Q&A session, so we'll defer some of those questions we don't get to earlier. We also have three very quick poll questions at the end, which we'd really appreciate your response. We'll get to them during the final Q&A. But enough from me. I'll hand it over to Nate, and we'll talk about gaming. Thanks, Nate.
Hi, everyone. Thanks for coming. As Dave said, my name is Nate Weiger. I'm the Principal Gaming Solution Architect for AWS. And what that means is I work with game companies worldwide to help them understand how to leverage AWS for their games. So I hope to share some of those experiences with you today to help you as well. So the type of topics I want to talk about today is just why AWS for games, why do game companies find it valuable, and then talk a little bit about what a core game backend looks like for games. And we'll talk a little bit about the data layer, which tends to be a big hot spot for gaming, and talk about options there. We'll talk about our new C3 EC2 instance, which has some really interesting multiplayer game applications due to its networking capabilities. And then finally talk a bit about game analytics with Redshift, our managed data warehouse, and Kinesis, our new streaming offering. So no presentation would be complete without the gratuitous logo slide, as I call it. But I do want to point out a few companies on here because we've got a good wide variety of use cases on AWS for gaming. So we've got mobile companies like Supercell with Clash of Clans, and most recently Bomb Beach, Rovio, Angry Birds, Half-Brick with Fruit Ninja. And then on the other side of things, we have console game companies like Naughty Dog and Nintendo, Sega. And then on the MMO side of things, we have companies like CMune and Red 5 Studios who built out their MMO Firefall entirely on AWS. So we've got a really good broad cross-section of use cases that are each using AWS in interesting ways. And through that, there's some common themes of why they find AWS valuable. So one of them is just the ability to handle viral spikes that happen. If your game goes to the top 10 on the App Store, for example, you can frequently see a huge spike in traffic. And that's actually what happened to DevSisters, which was a two-man shop out of Korea, actually. It had a wildly popular game, Cookie Run, that has now made it overseas as well. And literally overnight, the App Store ran a promo without telling them. Their actual server needs spiked from 2 up to 60 instances and back down. Didn't require any intervention on their part. And that was all enabled by AWS. So that's one important aspect that game companies find valuable. Another really compelling aspect is the fact that we have 10 regions worldwide now, same APIs everywhere. So games frequently start in one region. They might start off, say, in North America or Japan, etc. And then once they gain success, they want to go release in other regions as well. And what AWS enables you to do is use the same back-end APIs you've been using and just launch it in another region just by changing the location. So that's it for kind of core value propositions. Want to dig a little bit into the core game backend that a lot of companies are using. There's some common patterns here that really enable success. So let's talk about a game like Cookie Run, where it's literally two guys doing the development on it. What does the backend look like? What do people use on AWS to enable that? I want to talk about Elastic Beanstalk, which is a service that is increasingly very popular with mobile game developers. And what that is this a managed container that runs on top of AWS. And what that means is that it supports 6 different languages, Java, .NET, PHP, Node.js, Ruby, Python. So any of those languages, and all you have to do is worry about just uploading your code to Beanstalk. You can do it either via git push directly from the command line, or you can upload a zip file of code. And once you have that uploaded into Beanstalk, Beanstalk will take care of managing all of the other AWS services that previously you had to manage yourself. Services like our Elastic Load Balancer, EC2, our virtualization platform, or database services, DNS, etc. Beanstalk will actually take care of all of that for you, and all you have to do is just upload your code. And another side benefit is you get a nice web dashboard that shows the current version of your code running, allows you to roll back to previous versions, shows you the status of all your services, gives you a nice central location to look at. And a real key feature that sets Beanstalk apart, I think, from other offerings in this space is that it's the same performance as if you didn't use Beanstalk. A lot of times with platform offerings, you pay a performance penalty because you have to pay for that container layer. But the way Beanstalk is implemented is actually more of like kind of a macro templating service, if you will. So you get the same exact performance you would get as if you directly deploy to EC2. So there's really no downside to using it. You get full access to the boxes just like you would. And so bottom line, if I was a game company making a game, this is absolutely where I would start is with Beanstalk. So let's take a quick look at what that actually looks like. If you go onto our website, it's easy to find this basic canonical diagram, if you will, where what this shows is within a given region, shows multiple availability zones for redundancy, shows using auto-scaling on EC2, a load balancer in front of it, etc. And as I mentioned, Beanstalk will actually wrap around all of that, so you don't actually have to worry about those nuts and bolts. You just push your code to Beanstalk. It will take care of managing those auto-scaling rules and etc. for you. And a nice side benefit, actually, of Beanstalk as well is you're not off into some special area of AWS off to the side. You still have access to all of the other services that you would want to use alongside Beanstalk for your game. For example, S3, which is our HTTP-based file store, very widely used in gaming for binary data, game assets, etc. CloudFront, our CDN, all of those can plug directly into Beanstalk just by using the Beanstalk extensions capability that it has. Here's an example of the web dashboard just to see that aspect of it. Just thought it would be nice to visualize. And last slide on Beanstalk, and then we'll pause for a second. Here's what the actual flow would look like in terms of pushing your code. First of all, you just initialize Beanstalk using our EB command line utility. Write whatever code you want. This is a very simple Sinatra example in Ruby that just responds to a hello API. Commit it to your Git repository, push it, and then from there, Beanstalk will take your code, distribute it out, restart services as necessary, and so forth. Your choice of coffee or beer, or both, rinse, repeat. And there really is all there is to the workflow. It's actually really nice, very simple, and as I said, I would definitely use it if it were me. So any questions so far?
Yeah, we just have some about questions more than specific ones. Just a quick reminder to all attendees, we are taking questions interactively, so don't hold back with your questions. You have a question window or a chat window, you can just submit them, and we'll be asking them throughout the sections before we move on to the next one, as well as we'll have a longer time at the end to cover some more of those. But thanks, Nate.
Okay, great. So moving on from then Beanstalk, so that's kind of the core AWS service stack that I wanted to talk about in terms of just basic building blocks. If you have used AWS before or read through our site, you're probably familiar with EC2 and ELB, etc. Hopefully you see that Beanstalk can help simplify that workflow. And so I want to shift gears now and I want to talk a bit about databases, because databases really tend to be a sore spot for games, especially as they scale up. So what companies like Halfbrick have found, and they're not the only ones, is that once your game gets to a certain size, relational databases just become inherently problematic. And so what game companies have done instead is look at alternative solutions, typically NoSQL solutions, that rather than using kind of traditional relational ACID concepts, etc., they focus on high performance, key value access, more of a straightforward model, but actually accessing or emphasizing performance of the underlying data structure. So Halfbrick had a great study where they basically said they got to a limit with their existing relational databases, switched over to DynamoDB, our NoSQL offering, and we're able to then get past those performance problems and, of course, scale up to new levels. So why our database is such a problem for games? Well, there's a few reasons, actually. The main one is that games are notoriously write-heavy. So in a traditional web-based application, for example, it's usually about 10 to 1 reads to writes. That is, most people are reading and consuming content. They're reading online articles. They're watching videos, etc. You've got a few people that are maybe uploading content or commenting and so forth. But most of the activity comes on the read side. So there's a lot of opportunities for caching and strategies like that. But with games, it's actually the reverse. You actually have, it's not uncommon to have it 3 to 5 times or more writes to read. And the reason why is because there's just these constant updates. As you're going through the game, you're unlocking new content, you're leveling up, you're getting items and so forth. So all of those need to be saved in the database in real time. You know, players get very grumpy when you lose their progress. I'm sure we've all been there. So you really don't want to allow that to happen as much as possible. So you're constantly writing these updates. And they're typically pretty straightforward, you know, key value updates. You're saying, okay, Nate just got this item. Nate just reached this level. Nate just unlocked this trophy. Just key value, key value, key value over and over again in very high succession. In addition to the speed, you also frequently have binary data to contend with. Maybe you have item data or some other kind of binary data, and you want to save that in the database because you want that one source of truth. The problem is binary data is just not nice to relational databases. Relational databases don't like it. It doesn't matter whether or not you're talking about MySQL, Oracle, SQL Server, etc. If you look at the way they implement their handling of binary data, it frequently writes to an external table, and then there's all this extra work they have to do. So binary data and relational databases just really don't mix. And so all this stuff combined together really makes caching of limited use, as I mentioned. There's not much you can do to cache data that's changing 3 to 5 times as fast as it's being read. You can cache a few things like your top 10 leaderboard or your top 100, and, you know, most recent levels played or something like that. But you can't really cache a person's progress in the level because it's just changing too rapidly. And all of this combines together to make the database your bottleneck, and it becomes this red blinking light very quickly. So what can you do to overcome that? Well, this is where NoSQL solutions really have a key advantage for gaming. And I want to talk about DynamoDB, which is our NoSQL solution, which is very, very popular with mobile game companies like Halfbrick. So what is DynamoDB? It is a NoSQL data store, and what that means is that it is focused on key value access, and then it doesn't have some of the more complex transactional and querying capabilities that a relational database was, but it's optimized for speed. It's a fully managed offering that we provide. That means that you get an API endpoint. You don't have to worry about installing any software or maintaining backups. We handle all of that stuff for you. DynamoDB is designed to be highly available. It's actually distributed across multiple availability zones automatically within a region. Again, you don't have to worry about any of those kinds of details. You just get an API endpoint. And the way that you actually manage DynamoDB is via the provisioned throughput model. And what that means is you just go in when you create a table, say your leaderboard table or your users table or whatever, and you say, okay, I want this many writes and this many reads per second. That's what you pay for. And then we take care of actually provisioning that under the covers for you. And as I mentioned, you get an API endpoint. You just worry about putting and getting keys. That's all you focus on. You don't have to worry about how it's actually implemented. And just recently, we released a really compelling feature, I think, which is secondary indexes. So before secondary indexes were released, you literally just had the access by key and value. And that can be a bit of a challenge because usually you're going to want to do some kind of secondary operation. Maybe you're storing my score, but then you have a table with everybody's scores, and so you want to sort it and be able to say, okay, well, who got the highest score? Well, previously that was actually a bit complicated to do. You would have to store a separate table, et cetera. But we released secondary indexes, which allow you to do those secondary queries. Really opens up all of the compelling use cases. And you know, the way I think about it is any sane gaming use case at this point, in my opinion, is handled by the features that DynamoDB offers. DynamoDB is going to continue to evolve and continue to offer interesting things, I'm sure. But right now, if you look at the functionality that DynamoDB has, any kind of your traditional gaming operations, saving, retrieving data, sorting, etc., DynamoDB can handle. Regardless of your data store, you don't want to do complex operations in games. The data is changing too quickly. You don't want to have multi-table joins, etc. So just as a general rule, you don't want to do that regardless of whether or not you're using DynamoDB in another store. So all that taken together, in my opinion, DynamoDB has the features that games need. So I talked a little bit about latency, and this is a graph of DynamoDB actually as a service. And you can see, despite the dips and peaks of requests throughout the day, DynamoDB actually has a very consistent single-digit millisecond latencies. You can see that green line is just straight from left to right. And here are just a few links. These slides will be posted that you can see. These are links to the docs and SDKs, and then a cool third-party library that another person wrote, which what it actually does is look at the amount of throughput you're using in DynamoDB and will actually auto-scale it up and down, as I mentioned, that provision throughput model. So we'll actually tweak it in real time, just another way to make it hands-off for you. Last detail on DynamoDB as a service, and then I have 2 slides on some examples. I want to show a gaming example. DynamoDB really is designed for durability. Performance and durability are its 2 main properties that are kind of at the core of the service. So when you actually put a key into Dynamo and you say, okay, save Nate's new score, for example, you actually don't receive an OK response back from Dynamo until it has actually written the data redundantly to at least 2 locations. So that's not always true of other NoSQL offerings out there. If you look at many of them, they do things like cache in memory, etc., to get that performance. But DynamoDB actually writes it to 2 locations in disk before confirming that the request has been received. So just an example, just to give you a little bit more concrete information on what a leaderboard in DynamoDB might look like. The leaderboard is kind of the canonical use case, but there's many different things you could do with Dynamo. So in this example, we have the user ID, which is our hash key. And that just could be a numeric ID. It could be just my name, Nate, whatever, just depending on how your game is structured. Then it's got a range key. That's optional. It's kind of like a sub key. In this case, we have the game title here is the range key. So based on the user's name and then the game they're playing, that's their score. And all the other attributes in the table then are going to be unstructured and not indexed by default. You can put as much data you want on a row-by-row basis. Maybe some records have 2 or 3 attributes. Other records have 15 attributes. That's fine. That's the flexibility of a NoSQL data store. But then the question arises, okay, well then how do I actually do the sorting to get the highest score, as I mentioned before? And this is where secondary indexes come into play. You can now create a secondary index on the title plus the score. And what that'll do under the covers is that'll allow you to do that sorting like you would in a relational database. The last slide on Dynamo is what does that look like in code? This is just a really easy example in Python. We've got SDKs for all the major languages, as I mentioned earlier. So on the left side is what you do to create the table, create the index. You only have to do this once, but that just gives you an idea. There's just a few lines where you actually say, okay, here are the columns that you care about. And then on the right side, when you actually do the query, that's where you say, okay, use this index. Then you get back the scores in that order. So this is a very common pattern for games that are actually leveraging DynamoDB and how they're using secondary indexes. All right, so that's it on Dynamo. Any questions on this topic?
Yeah, hi Nate. So we'll get through a couple of these and then we'll keep going. So firstly, where would I use DynamoDB instead of something like Redis, for example?
Yeah, great question. So I'm personally a huge Redis fan. So the 2 are actually kind of complementary techs depending on how you look at it. So DynamoDB, what that gives you that Redis doesn't give you is it gives you that durability. It gives you the assurance that once you store data in it, it's there. You're not going to lose it. Whereas Redis, part of the reason, again, this is kind of what I was mentioning about other solutions out there, part of the reason why Redis is so fast is it's all in memory. So periodically it's going to be writing out to disk, but that's not the same as it actually writing to disk in real time. So there's some possibility of actual data loss with a technology like Redis. So sometimes what game companies do, and this is actually what I did in my previous life when I was building games, was they'll actually use Redis and DynamoDB together, for example. So what you would do in that case is you would store the score into DynamoDB, and then you could also put the same value into Redis, and then leverage Redis for its speed of being able to do that real-time sorting. But again, there's a bit of overlap there because DynamoDB can do that as well. So it really depends on your use case whether or not DynamoDB is sufficient or whether or not you have, say, just a big enough data set or some other criteria that's going to say, okay, Redis has certain advantages in this case. If you are going to use Redis, definitely look at our ElastiCache for Redis offering. We just updated it to the latest version of Redis recently. And it's a great way to use Redis with DynamoDB together. You can spin up an ElastiCache for Redis cluster, very similar to Beanstalk. It's a fully managed product, so you just select the size of Redis you want, and then we'll take care of provisioning it and so forth. And then you can use those two together if it makes sense.
Great. Thanks, Nate. One more question at this time. So we have, Rikas mentions they use Beanstalk and it's great. How can you explain how you would use DynamoDB in a worldwide rollout of an application or game? Some background to that, they're currently using Mongo, have to self-manage sharding, things like that, and would prefer not to. So, and to the question on would you ever make a Mongo offering, we won't comment on roadmap, but we love that sort of input. So thanks for that, and we definitely write that down, but I can't respond to you right now on that. Could you refer to how you'd roll out a global game, Nate?
Yeah, that's a great question. So when you're talking about global games, you kind of have a couple different options for the way you want to architect your servers. A lot of times what people tend to do is when they're just thinking of it as a first pass is they want to, they figure, well, it'll be easiest if we replicate all of our data everywhere, and they'll use technologies like Mongo or MySQL's global replication to actually replicate all of the data across all of the different regions. There are some use cases for some pieces of data where that is kind of a necessity, maybe for global state, but there are other ways to accomplish it. But I think what game companies a lot of times find is that ends up just being a huge maintenance headache as well as a huge time and cost sink, right? It becomes very expensive to have a very large ring of databases running worldwide. So the other two strategies that people intend to do instead now is that they'll as much as possible have most of their data maybe in one central location. Say they had most of their user data, et cetera, and it was accessible via web APIs. They would have, say, a Beanstalk app with DynamoDB underneath, and they would use that central location where they would actually log in. Say that would be running out of Virginia, for example. And then if there was lower latency stuff, say game servers and such, those would be located in the different regions near the end users, but those wouldn't necessarily have the same data. So that's one option. Another option is to actually home users to their primary region. And even for MMOs, this actually works well in the vast majority of cases because of the fact that most users play in their home region. If you look at their typical patterns, they typically play in the same area with kind of the same clans, et cetera. So in that case, what people end up doing, in the MMO world is saying, okay, your primary region is, say, West Coast US, you're mainly in Oregon, or you're mainly in Singapore, and having the user's data be local there. And then if there's a few pieces of, say, global leaderboard data, that can easily be then replicated up to a common place. And if a user wants to then move over and move somewhere else later, which again is an infrequent occurrence overall, they can then actually take that data and say, okay, well, I'm going to move over now to West Coast US, and now I'm going to play over there, and even move back. And those processes, especially when you're using something like Dynamo, are pretty straightforward because the data is unstructured. And so you can just kind of pull those records out and put them in the next one. It's actually easier to do that kind of thing than with a relational database, excuse me. And so last thing I'll mention on that topic is it's actually really fascinating. It's a big discussion, and it's definitely interesting. I actually talked a bit about that at GDC. I think we're going to send out some of the slides from GDC, but you can also search on them. If you just search under my handle, NateWare, you can find the slides from GDC. And I actually have probably a half dozen slides on some of those different options where we talk about what to do for global games in that situation.
Great, thanks Nate, and we will get those links out to everybody. Just a quick point on the sharding. You do get some control over that in DynamoDB from the application perspective, and that's what the hash key is. So the hash key is, we use that, actually we hash the hash to determine how broadly we partition it. And so as you dial up your throughput or your storage increases, we will increase the number of partitions that data resides on. And obviously for throughput, we'll increase the power to that as well in terms of network and processing. So that's all handled for you at the back end, or you just worry about a nice high cardinality hash key, and the rest takes care of itself. So that's great. We'll get back to, if there's more questions, we'll get back to them a bit later, but continue on. Thanks, Nate.
Okay, great. So we've talked about Beanstalk for that core application. We've talked about Dynamo and the challenges with databases. So I want to talk a little bit about now our new C3 EC2 instance. In the context of large multiplayer games, Supercell with Clash of Clans is one example. Also mentioned Red 5 with their MMO, Firefall, which is built entirely on AWS. So C3 actually offers a lot of very interesting applications for gaming. And so C3, the name comes from C being our compute-optimized family and 3 being third generation. And there's a number of things that it offers that our previous instances haven't. One of them is a very high packet per second rate. Previously, you could get a few 100,000 packets per second out of our instances, which is still a good number. With C3, we've done some internal tests and found that, and customers have said as well, that you can get over 1 million packets per second, over 1 million concurrent connections. So it's a significant jump up when you talk about network performance. And along with that, outside of just your actual performance, you get much lower latency and jitter than you did historically. And included also in the instance is an Intel Ivy Bridge CPU. What you'll see in our instance details page now, if you go to our website and you look through our EC2 instances, you'll find that we're being much more transparent in the way that we talk about the CPUs that are on our EC2 instances. Previously, we focused a lot on kind of abstract concepts like compute units, etc. What we're actually doing now for our newer instances is saying, okay, this instance is going to be this type of CPU, and that's something that you can rely on anytime you get an instance in that family. And there's also SSDs on board, which are great for writing state in the case of games. And altogether, the way I look at it, these really are built for games. We've got a number of game studios that have tested this and just found just a world of difference over previous instances, and it all starts for 10.5 cents an hour. So what I want to show you then in the next couple slides is how to actually use one of the new C3 instances and enable the enhanced networking capabilities. And first, what is enhanced networking? So under the hood, that's a new technology called SRIOV, Single Root I/O Virtualization. If you want to read about it, you can search for it, and there's articles kind of explaining the nuts and bolts. But in a nutshell, before this technology, the hypervisor had to actually handle all of the different network interrupts. So anytime any of the virtual machines wanted to send a packet, the hypervisor had to catch it and then load balance between those and send those all through the NIC. So there's a lot of processing power required from the hypervisor that took away from the throughput that the virtual machines could get. With SRIOV, what actually happens is it actually pushes that down into the hardware layer, pushes it down into the firmware in this form called virtual functions. And I won't dwell on it, but the net result of that is that as far as the hypervisor sees now, there's actually separate network interfaces. So rather than having to do any kind of software switching at the hypervisor layer, it just passes it through, and then the hardware actually takes care of balancing those. And obviously, the hardware is going to be much faster at it. So how do you launch a C3 to take advantage of it? Well, there's a number of different steps that you have to do. If you follow these, then you'll get a C3 in the proper configuration. The first thing you have to do is you have to make sure you choose an HVM machine image. What that means is there's two different kinds of virtualization. There's PV, para-virtualized, and then there's HVM, hardware virtualized. They're just two different approaches to virtualization. Again, you can read about it. HVM is what Windows uses, and Linux can kind of use either one. So you have to make sure when you're choosing an image that you look for the virtualization type being HVM. And the problem is it's in little tiny itty-bitty font down underneath it, unfortunately. This is on the launch instance page. So you have to, as you're scrolling through images, just make sure it says virtualization type HVM there, and then you'll be in good shape. So that's step one. Step two then is you want to obviously choose a C3 instance, and to do that, you click on the left side, Compute Optimized. We've started breaking apart our different instances into families when you're launching them, just because we've got such a large list of instance types nowadays. So you click on Compute Optimized, and then on the right side you choose the size, large, extra large, etc. And then don't click the blue button, as tempting as it is. You have to actually, this is the third step, you have to configure the instance details. And this is the last thing you have to make sure to do. At the network part of it, you have to use VPC, which is our virtual private cloud. Now, if you have a recent account, or if you either just signed up, or if you already have VPC, if you've been using it actively, this should be pretty automatic for you. But if you've got an account you've had for a while, like myself, the default is actually going to say something like launch into EC2 Classic. That would not enable you to make a use of the new SRIOV functions. You actually have to change that so that it selects the VPC. And so it'll look like this. The box will expand once you pull it down. I've checked public IP because I was using this to test actually network throughput, but that's optional. But once you select the VPC, then at that point you can click the blue button, and that should be all you have to do. The instance will spin up, and then you'll be good to go. So just a quick recap. Again, use an HVM image. Linux, you have to be careful. Windows are HVM, but Linux, you have to make sure that it's an HVM image. You obviously want to select to actually use the C3 instance because our other instances don't have this capability yet. You must launch in a VPC, as I mentioned. And then if you want to just make sure that everything launched correctly, you can actually use our command line tool with a -- attribute in the SRIOV, and then that'll tell you, it'll print out and show you that SRIOV is enabled. And full documents are available at this link. If you read through that, it's basically the same kind of steps. So you can go there for more details as well. So in addition to C3, we have another interesting instance that's actually really compelling for games. That is the new G2 instance. And G2 is actually our first instance that includes the GPU. It's an NVIDIA Kepler GPU on board. And it's the first instance where you can use the GPU as an actual frame buffer. Previously, we had a CG1 instance where you could use the GPU via CUDA instructions, etc. So it's kind of interesting for HPC and applications like this. But now you can actually use it to actually render stuff. And you can, the obvious application there is game streaming, right? If you think about that, you could actually stream your whole game down. But there's other interesting ones as well, in my opinion. One of them would be rendering assets. If you're doing something that has a build step and you want to actually render out some 3D assets, spin up a GPU-based instance of G2 and render out those assets and then spin it back down. Build servers, similar idea. You know, previously the approach was a lot of times throw a whole bunch of old PCs in the closet and push out to there, but now you could push it up to the cloud instead. And then AppStream, which is our streaming SDK service that we released just recently, is actually built on top of the G2. And there's a really cool demo that EVE Online did with their character creator. And so this is kind of one of those things that is really, in my opinion, really kind of thought-provoking. So what they did is not so much stream the whole game, right, which is kind of your obvious, oh, you just stream the whole game. But they did something actually really interesting that has a lot of bang for buck, and that is they made it so that while the user is actually downloading their game, which is, you know, many gigabytes in size, they have just part of their game, just a character creator where you customize yourself and get all set up and et cetera. And if you've ever played EVE Online, you know that's actually a pretty long process. It can take you half an hour or so to actually set up your character. So you actually do that via your tablet or whatever you want to. It's streamed from the cloud. And then basically the same time that you're done doing that, then the game is done loading, your character is ready to go, and you can jump straight into the game. So it's really interesting kind of hybrid experiences like that I think are going to be most compelling out of G2 and out of AppStream, rather than just necessarily streaming the whole game. So maybe that kind of spawns some thoughts. So that's it on EC2 instances. Questions on this?
Yeah, just want to talk about the C3 instance requires VPC. Can you just talk about if there is there any overhead for running something in VPC?
No, actually, no. A VPC has a very good latency profile. Actually, the reason why we require VPC is because it's kind of our second generation network stack, if you will. So you can get better performance out of VPC with C3 in our newer instances than you're going to get out of EC2 Classic.
Great, thanks. And probably goes back to more of a beanstalk, although it's not mentioned. Can you comment on the difference between ELB, elastic load balancing, and cloud formation, and probably with some beanstalk context?
Oh, sure, yeah, sure. So what ELB is that's our load balancer as a service. And so what ELB does is it sits in front of multiple different EC2 instances and round-robin balances between them. So say like, if you just have a typical REST API and, HTTP-based, from one request to the next, it would route to different EC2 instances behind the ELB. You said CloudFormation. I think you might mean CloudFront, our CDN. So CloudFront is actually, it can be used in concert with ELB, but it's a different use case because what it's designed to do is conquer last mile latency. So it's a content delivery network. You could actually put it in front of ELB, and so CloudFront has 51 points of presence worldwide. And what that enables you to do is, say you have an end user in a remote location like India, for example. It's going to give you better latency hitting a CloudFront POP than going all the way back to, say, an S3 bucket. So if you want to use the two together, what companies do, what game companies do, and then web companies as well in this case, this is kind of a common usage pattern, is they'll put CloudFront out in front of ELB and use CloudFront to cache that end content. But you can't use CloudFront in and of itself just to load balance between EC2 instances in the same way. Hopefully that makes sense.
Yeah, great, thanks. And just to be clear, CloudFormation is a template where you basically define your assets and automate the launch and so on of those infrastructure assets.
Yeah, sorry,
great.
Good point. Good point.
Yeah, thanks, Nate. Let's keep going.
Okay, great. So last thing I want to talk about is game analytics. So this is going to be a little bit of drinking from the fire hose because we only have about 20 minutes left, and at GDC I blabbed for an hour on this topic. So if this is interesting to you, I encourage you again to follow those follow-up links. Hopefully we'll get video from the GDC talk as well, and if we do, we'll make sure to send that out. But what are companies like Rovio doing for game analytics with AWS? Rovio recently, posted a case study, and they talked a bit about how they're using Elastic MapReduce, our managed Hadoop offering. Supercell was highlighted at our San Francisco summit. Actually, Andy Jassy, our SVP, talked a bit about how they've built a whole analytics pipeline with Kinesis and Redshift and so forth. So what are these companies doing? What does that look like to actually learn about their players? So before we get too far into it, what are we actually trying to analyze? Well, what we want to find out is whether or not people are liking the game, whether or not they're having fun, or whether or not they're getting bored, stuck, etc. But you can't directly measure that, unfortunately. So you have to translate that into some kind of metric you can measure, maybe where they are, number of hours played, etc. And so once you've defined that data, then here's kind of a common, typical analytics flow. There's some variations on it, but this is basically it in a nutshell. So you've got ingest, which is how do you get your data from users, storage, where you're actually going to put it in the cloud, processing is actually making it into a format that you can do something with it, and then analyzing is you looking at the data and trying to make decisions, and then ultimately profit, of course, right? Apologies to the gnomes. So when you're first starting out, a lot of times game developers look at using an off-the-shelf product, and there's a lot of good ones out there, Flurry and such. And they're nice because they're easy to integrate, and you get some pre-baked out-of-the-box reports. What developers frequently find is that you wind up getting limited in the amount of data and how long you can save it, and your data kind of winds up in another system. So if you are going to go down and use one of those off-the-shelf tools to get started, which can make sense because time is short as a game developer, just make sure they have some kind of data export API, because a lot of game developers get to that point where they say, okay, now I really want to take control of my data, and you're going to want to be able to get the data back out. So putting aside off-the-shelf solutions, how could you start just with AWS in just the simplest way possible to hit the kind of 80-20 rule, right? So here's a model that we recommend. One is just start writing events on the device. Just have a time stamp and just user's name and say, here's what they did. They logged in, they started a game, they leveled up, etc. Periodically, then take that and put that into S3, our HTTP-based file store. You just do an HTTP put it up there. Don't worry about all the analytics and analysis you're going to want to do with it. Just get it on S3. The main thing is if you don't collect the data, you can't analyze it. Just collect data from day one, put it onto S3, come back to figure out what you're going to do with it later. And once it's on S3 and once you have a little breathing room, you can load that data directly into Redshift. As I mentioned at the start, Redshift is our managed data warehouse as a service. The way you spin it up is kind of similar to how you would spin up one of our RDS database instances or Dynamo, et cetera. You just say, okay, I want this much memory, this many CPUs, and then we'll actually take care of allocating a cluster and getting it all set up for you and giving you an endpoint. And then once you have that endpoint, loading it into Redshift is actually as simple as just a one-line command. You just say load into this Redshift table from this S3 bucket, and then Redshift will actually take care of streaming the data in parallel and loading it in for you. And once it's in Redshift, Redshift is a SQL-compliant database. Any of the familiar SQL tools you have out there will work with it. Tableau, Pentaho, Jaspersoft, all very popular choices. You can literally just point that tool at Redshift. Redshift talks SQL, and then you can do all of the kind of visualization stuff you would want to. And then profit, right? But I want to pause for a second because this slide literally, if you just do this, you will be eons ahead of where many game companies are. This will definitely get you 80+% of the way there. I'm going to talk in the next few slides about some kind of exciting new stuff, like the companies are starting to break new ground and some really interesting things to think about. But I want to just emphasize that if you start with this, you can always add on the other stuff later. So this is an example of Tableau plus Redshift. This is on their website. There's a link there. Point just being is if you look at the left side, you're just setting up Redshift as a typical, common SQL connection point. And then the right side, then you can do all of the kind of graphing that you would expect to do. So you've got that core in place then. The next thing you're going to probably want to do is say, okay, well, let me look at some more data sources. I've got my data coming off of my client devices. What other kind of stuff can I collect? Well, you could start with server logs, right? You already have those servers running under Beanstalk, et cetera. They're already spitting out Apache logs or whatever else. No reason to reinvent the wheel. Just collect those. There's lots of interesting data in those about who connected and how long they spent, et cetera. And just periodically upload those to S3 as well. Just put them in that same S3 bucket. I can't emphasize enough. Just get all your data on S3. Just use it as a big, giant holding bin, and then figure out what to do with it later. S3 is very inexpensive, especially with our most recent price cuts. You can store gigs and gigs of data there for almost free, in my opinion. And then, as I mentioned, ultimately just load it all into Redshift. Once you have some breathing room, you just issue those commands, load that data into Redshift. Redshift will organize it for you and enable you to query it. And you can do that with your external data analytics too. So if you did start with one of those off-the-shelf tool sets and you decide, okay, I want to take control of my data, you can use their export APIs, export it to your S3 bucket, and then bring it all back into Redshift. And so the point being is that, if you view Redshift really as your ultimate source of your ultimate destination for your data, and S3 as your holding area, if you will, you can just bring as much data as you want through S3 and then file it all into Redshift once you figure out what you want to do with it. And going back to what I was mentioning about the Elastic Beanstalk, so if you go that route and you make use of DynamoDB, kind of nice thing about DynamoDB is it actually has an adapter for Redshift as well. So you can actually directly load into Redshift. Very similar command that you would use to loading from an S3 bucket. You would just say load into Redshift from this DynamoDB table, go. And then what Redshift will actually do is actually pretty cool. It does this intelligent merge where it will actually look at the columns that are coming from DynamoDB and look at the columns that are in Redshift and figure out which ones it should load and which ones it shouldn't. It tracks, as I mentioned, it tracks those DynamoDB columns, and essentially If columns are there, then it loads them. If columns are missing, then it can fill them in with nulls, et cetera. So it's really nice. A lot of the kind of common fix-up you would have to do when you're loading data is actually taken care of by the adapter in this situation. So let me go back and just pause on this. So this is again, this gets you to, in my opinion, 90+% of the way there. If you have a setup like this, you're going to have just tons of really useful data about your game, and you're going to be getting data from your real-time actual game servers. You're going to be getting data directly from user devices. There's just a lot of analysis this is going to enable you. Just pull it all back to Redshift, and you can just do a lot of really interesting digging into what your players love or hate about your game, right? Both are equally important. So last few slides, what I want to talk about in game analytics, and then we'll have some Q&A. So real-time is interesting. If you think about the stuff that you're doing, so far we're talking about batch analysis, which is great and very, very valuable. But think about what you could do if you could react more quickly to users. Think about that event stream I'm showing. This is actually kind of happening in real time, right? You have these users playing throughout your world, multiple different users doing different interesting things. And think about if you could actually capitalize on that and have a game that reacted in near real time. It's simple, easy things you could do. For example, say everybody was in the same part of the world or using the same kind of items, or there was a peak in usage. Any of those, you could run some kind of promo and say, hey, limited time off, sale on this, or sale on these specific items. There's lots of that kind of stuff. If you could react in near real time, that could be very interesting and actually very profitable for the game as well. So what does that look like? So we've got our system built out. We've been using S3 as our bucket. So this is where Kinesis comes into play. Kinesis is our new streaming data transfer service that we just released. And the best way to think about Kinesis, in my opinion, is just kind of think of it as this data mesh. It's just this kind of input-output. It's almost like a bus, if you will, where you can just stick a whole bunch of stuff into it and have a whole bunch of stuff coming out it on the other side. And so what Kinesis would do in this situation is it would take the place of our S3 bucket, and rather than loading data into S3, then what we're going to do is we're going to write data into Kinesis from all of our different sources. We're going to write to it from EC2. We're going to write to it from all of our devices that are out in the wild. And we can still output to Redshift. So I really want to emphasize, again, you're not going to have to start over. You're talking about getting to a point where you get to a certain level of being an advanced kind of expert user. You start doing stuff in real time. You just swap out where that holding area is rather than holding it in S3. You now use Kinesis to transport it. All of your back-end analysis still works the same. All of the stuff you already set up with Redshift, you can still keep doing all that analysis. You don't have to start over. And so in addition to doing that kind of nightly or weekly analysis, now you can do stuff that's more real-time. Spark is a real-time analytics framework that runs on top of Hadoop. Really, technically, it's a Hadoop alternative, but it runs on top of Elastic MapReduce, which is our cluster management that is typically deployed with Hadoop. So you can use Spark with EMR. We have resources online to show you how to do that. And you can also stream to other alternatives such as Storm, which is a very popular open source framework. And you can write your own EC2 code as well. Say you wanted to do a couple different things. Say you had real-time information about where people are in the world, or where you're writing a multiplayer game, and so where people are in the map, that's streaming through. You want to make decisions in terms of, hey, maybe I want to run some kind of sales data or something like that. You could do that through Spark, and then you could have EC2 instances that could do interesting things like rendering real-time heat maps or showing where people are on the map. So there's really interesting stuff you can do with Kinesis because of the fact that it has this concept of just multiple ins, multiple outs, and you can connect things in multiple ways, many to many. And then you can keep offloading to S3 as well for longer-term archiving. Kinesis will retain stuff for 24 hours, so it's intended more as a real-time transport. It'll do some requeuing and stuff so that if there's hiccups, it'll keep that data for 24 hours. But if you want to do long-term storage, then you can keep offloading it to S3. So really, you could think of S3 in this case as continuing to be your long-term store, and just you're adding Kinesis to do more real-time, and you're still pushing off data to S3. And you could just as easily load data from S3 into Redshift if you don't want to change that process up front. You could just keep that arrow if you envision it going from your S3 bucket to Redshift. Then that would be identical to what you had previously set up. So that's it for my talk today, and then we have about 10 minutes for Q&A. Just quick recap. Start simple with Beanstalk. I highly encourage you to try it out. In my opinion, it's just a great service. Really take the time to look at DynamoDB, relational databases at scale for games, and just continue to be a challenge. We talked about our C3 instance. Hopefully that gave you an overview of how to make use of that. And then simple analytics, 1, 2, 3. Just take some kind of CSV or JSON or whatever data you want to record, put that into S3, put that into Redshift. And then finally, when you start talking about real-time data, Kinesis along with real-time analysis like Spark and so. So that's it, Q&A.
Great, thank you, Nate. Yeah, we do have a few questions, so we'll get through those, and when we're done, it'll be a wrap. So a quick question on the SRIOV. Does that capability exist between G2 and C3 instances?
G2 does not have SRIOV on it at this point.
Okay, great. You mentioned you had an example of Python with DynamoDB. I think it was a leaderboard example. Do you have any C++ examples?
Good question, Dave. I don't know if you want to comment on just the type of stuff we're trying to do for Dynamo, like extra examples and such.
Yeah. So to that point, specific code examples we don't have yet in C++, but it's something we're looking closely at. So thanks for all the feedback, by the way. We know that's big in gaming, and I'm sure we'll be responding. With Dynamo, DynamoDB, what we're focusing on is helping people. We do this a lot with our customers on getting the design right. So the thing about a managed service is it's all taken care of once you've got your application on top and running. But the focus then moves to making sure that that application is well formed, well written, well designed for scalability. And so we're looking at various different options. We hope to be announcing a few of those shortly. So pretty excited by that. A couple more questions. How do we convert JSON data from game servers into Redshift?
Sure. So if you have JSON data, so let me back up. Let me start with the end state first. So Redshift, the easiest way for it to load is you can just pass a delimiter as part of the loading command to Redshift. So you say, okay, load this data and have it be pipe delimited or comma delimited. So that's the easiest way. Redshift has that built in already. What people commonly do if they have, say, data that comes across in JSON format is that they'll have a little piece of code which you could write as part of the Redshift load that would then just normalize that out into either a CSV format so that the data is kind of in the same order or pipe delimited or something like that. So typically the way you would, and I talked a little bit about this at GDC, but the way you would load data in Redshift is setting up kind of a nightly process. We have a good article online about setting up a nightly schedule of load into Redshift. As part of that, then you could have a couple lines of script that would then go through that data and actually clean that up and change that around and get it into the right format, if that makes sense.
It does. Great. So a question on DynamoDB, which I might handle, but I'll let you get first shot at it. What are the effects of under or over provisioning your read-write rates with DynamoDB, and how does that interact with auto-scaling?
Yeah, I will definitely let you handle that, Dave. I mean, I think you'll do a better job than I will. Yeah, go for it.
Great, yeah. Okay, so the first thing I think conceptually is to understand provision throughput. Provision throughput is in the same way that you would allocate a resource like a C3 instance, you set provision throughput. So think of it as your maximum server capacity. So under that ceiling, then you operate your workload. So what are the effects of over-provisioning? It's just cost, as it is with an EC2 instance. But if you have a very spiky workload, you do what you do in the normal world when you're allocating instances, and that is you have to provision to near the peak. So you have that. We encourage the same approach with DynamoDB, with the added advantage of the ability to scale it up and down kind of seamlessly. Without any impact to performance or availability during those transitions. So you could go from 1,000 to 2,000 writes a second, for instance, and you will get 1,000 writes a second while the back end is allocating all the resources to get you to 2,000. And after those, it's typically a few minutes when that time is up and all the resources have been allocated, your ceiling will now move to 2,000. So there's no performance impact at all. In fact, obviously, if you're over-provisioned, then it's just about cost. Under-provisioning, you will have a similar experience to that which you would experience on a server that when you hit capacity, and that is you'll hit a ceiling. In DynamoDB, that's what we call a throttling event. You will be throttled if you approach your capacity. However, we do have some ability to mitigate that. So there is a limited degree of burst, which we also allow. In CloudWatch, you will see on the single graph, you'll see your read provision versus used and your write provision versus used. It's two different graphs, but we'll overlay the used and the provisioned. And so as one encroaches upon the other, as you're using capacity and that's increasing, you can get an alert that will tell you how you're getting close to your limit here. You may want to think about it. So that's all kind of background to the auto-scaling. Now, the auto-scaling is a library that Sebastian Dahlgren wrote. You can link to it from our DynamoDB homepage under Developer Resources, and it's called Dynamic DynamoDB. So what Sebastian wrote was basically a library that monitors those CloudWatch metrics, and when that encroachment starts to appear, you're getting within, say, 20%. I think that's adjustable of the provisioned allocation. It will automatically trigger an upscale event. And so that will happen for you automatically. There's no limit to the number of upscales you can issue in a day. We do have some limited downscale events. So I think it's 4 in a 24-hour period. But autoscale will also accommodate that. So when your workload pressure dies off, then it will downscale to save cost. And so that's the experience you'll get with autoscale. Question for you, Nate, and you can see the poll questions up. If you could give us a quick response, that would be great. We'd really appreciate that. Does Redshift, it appears Redshift doesn't handle unstructured data. That's kind of the comment. Could you, question on that, is that accurate? Anything else?
Yeah, good point, and I know I had to, just for time, I kind of skimmed over some of those details. Redshift is a columnar database, so it's similar to a relational database. You do have to define your columns ahead of time. The advantage that Redshift has is it actually organizes data in a columnar fashion, which gives you very high-speed access to doing aggregations and queries across data sets. That you had 10 million records, and you said, just give me the average play time for these most recent sessions. That would be a very fast calculation to do in Redshift. But the trade-off there is you do have to predefine your columns similar to a relational database. So for truly unstructured data, that's where Elastic MapReduce, which again kind of glossed over. But in my GDC talk, I spent a good amount of time comparing and contrasting those approaches. Unstructured data is where Elastic MapReduce really shines if you just have data in a whole bunch of different formats. And so frequently what people end up doing is they'll use Elastic MapReduce actually as part of a workflow where they'll bring in all of that unstructured data, if they have a whole bunch of ad hoc analysis, do that in code because that's the way Elastic MapReduce works. It's more of a coding foundation. And so they'll do that in code or using some kind of custom query language like Hyper-Pig. And then as part of that, they will also output a more structured set of data that then could be loaded into Redshift. And the advantage of using Redshift then is the fact that you get all those nice GUI visualization tools and all that stuff that works out of the box.
Great, thanks. So another question with MySQL. There is a point where you can overwhelm an instance. With DynamoDB, is there a transaction level or input quantity at which point it will simply fail?
Dave, that would be a good question for you too. I think yep. You'll have a good answer.
And it's a short answer. No, there's no point. It's designed for unlimited capacity, both in terms of on-disk storage and throughput. So the principle of distributed systems is, we take the data, we keep distributing it to give you more and more resources. So, there are theoretical limits, which are, how much hardware we have available, but we keep well ahead of the demand on that. So for all intents and purposes, there are no limits. We have customers running in the millions of transactions a second. I think we've got time for one more. The batch load into Redshift. A quick comment on that. So I refer you to the Redshift documentation. It's very comprehensive, and there are best practices guides. That applies also for DynamoDB. We do have best practice sections, particularly in Redshift. It's about data loading. It's about fast inquiry, making fast queries. So there are a lot of nuances to that. To get it right is really simple, but there are ways you can always optimize. So yes, very much encourage you to look at that. And if you want to write to us, if you can't find those links, please let us know. But that is a wrap. That's all we have. We're at the top of the hour, so really appreciate your attendance. Thank you, Nate, for your content. We will be following up with emails with all the links to the content here, and we'll see you next time. Thank you very much.